Well, welcome to Chapter 5. So, in Chapter 5 is linear functions, and 5.1 is proportionality. So we're going to explore proportionality in equations, which we've already done, and I'm going to do a quick example of that before I move on. And I'm going to explore proportionality and show how the equation relates to tables and graphs. It's basically the most simple function that we have. And we're going to expand that function to include all linear equations. So I'm going to give you a quick example here on the next page. So here's an example, I believe, from like chapter 3. So we have, it takes 5 Canadian dollars to have the same purchasing power as 350 US dollars. So I'm going to create an equation that relates these two. And the way I'm going to do it is just to simply set up a proportion. Now you can pause this at any time and think about what I'm going to put here. So I have 5 Canadian dollars is the 350 US dollars, as Canadian dollars is the US dollars, using C and D, obviously. So now I'm going to cross multiply, and then I'm going to solve for, I can solve for either one. So if we cross multiply, think about this, here's what we're going to get. So I'm going to get 5D equals 350C. Now I can solve this for D by dividing by 5, or I could solve this for C by dividing by 3.5. I'm going to do both just to show you. Okay, so I worked out the problem. For this one, here's after cross multiplying, divided both sides by 5, and I get dollars equals 0.7 times C, or if I do it the other way, divide both sides by 3.5, I get C equals 1.49 times dollars. Now let's just look at this one. Extremely importantly, that 0.07 is a ratio. It is not one number. It is $0.7 divided by 1 Canadian dollar. Right? I hope you understand that, because that is K, but it is a rate. So now let's just look at what this does in an Excel file. It's going to run a table out. Okay, so here we have our equation. US dollars equals 0.7 times Canadian dollars. And I'm going to fill in this table of values. And that's pretty simple. I'm just going to start with the first one. US dollars equals 0.7 times Canadian dollars. Now over here, I'm going to have it draw a chart as I fill down. That is the crucial point. In a proportional relationship, if you have 0 of one, you better have 0 of the other. That is a defining characteristic of a proportional relationship. One of them. And here's the other. Notice that it forms graphically, the data points form a line. If you take X, Y, 0, 0, 2, 1.4, about right here, 2014, it forms a linear relationship. It's a line when you graph it. Now the other thing to notice is that all the ordered pairs, right? These are ordered pairs, X, Y, that they're all ratios. They're all proportionally related. In other words, 1 over 0.7 is the same thing as 2 over 1.4 is the same thing as 10 over 7. So we studied this in chapter 3. The main thing to remember here is that all of the solutions to the equation are proportionally related, and that when you graph a proportional equation, you get a line. Now here is two relationships. These are phone plans. The blue one is 5 cents per minute it costs. And the orange one, or the yellow one, is 7 cents per minute. So here's a table of values. And this is the cost. These are how many minutes, the cost at 5 cents, the cost at 7 cents. And they're graphed on the line. Now, most importantly, 0 minutes is 0 cents in either way. 1 minute's 5 cents, 2 minutes 10 cents, 3 minutes 15 cents. Notice the difference here in the slope of the line, right? The 7 cent plan is steeper because for every 1 minute you have to pay 7 cents. 2 minutes you pay 14 cents. Now this is the rate. This is a rate that you learned in algebra. The constant of proportionality is the slope or rate of change. Notice it's not just cost equals minutes times 0.05 for this. It's that the rate itself is a rate, so it's two things. So here's now where it changes a little bit. All right? We're going to have this, and we're going to get the cost is proportional to the minutes you speak at a rate of 5 cents per minute. So there's the rate, right? There's the slope. 5 cents per minute. Now assume that there's an additional fixed cost of $20 each month. All right, so this is where now an initial value comes in, and we go from a proportional equation to a linear equation. That's the only difference. The only difference between the two is that a linear equation is going to have an initial value, whereas a proportional relationship will not. Right? So we just build this out. It's pretty obvious to see how that works. So I'm going to do one example here. Okay, so before I do that example, we're going to let's just look at what's going on here. Here is 5 cents a minute. Here is 5 cents a minute plus an initial fee of $20. This is the proportional equation. This would just be the cost equals 5 cents times the number of minutes. Where here, it's going to be the cost equals 5 cents times the number of minutes plus 20. So this linear equation is of the classic form y equals mx plus b, and it has an initial value. Where our proportional ones do not. The initial value is 0, 0. And this just gives an example of that. I'll do a few and then I'll put up the answers for you, right? So the weight of water is proportional to the volume at a rate of 8 pounds per gallon. So there's the rate, gave you the slope. 8 pounds per gallon. That's for this one. And this one here, next, assume that the bucket you're using to carry the water weighs 10 pounds. So that's different. You have a bucket, it weighs 10 pounds, and you're going to put water in it. This one should be obvious. It is, well, it should be 0, 0. That's 0. Gallons are 0, the weight of the water is 0. This one, gallons is 0, but the weight of the bucket is 10. And I will put these up, but it's just simply a matter of 0.5 times 8, right? 0.5 times 8 plus 10, and I will put those up. And what we're going to see here on this graph, and I will graph this for you, is that the lines are going to be parallel. They're going to have the same slope, but this one is going to start up at 10 here. I might be able to draw those in, but let me get this other one up for you. So here are the answers to the table of values when different gallons of water weigh a different amount, and then they weigh 10 pounds more because you're carrying a bucket. This is a proportional relationship here, and it's linear, and it starts at 0, 0. This is of the form y equals mx plus b. And I'll just show you the graph here. There's the graph. It starts at 10 because for the second one, the bucket weighs 10 pounds, even without water. Notice though that they're parallel because the slope is the same. The steepness is the same. The slope is the steepness.